Everyone, it's Miss Berlinga. So today we're going to be talking about polar and non-polar covalent bonds. So this is for AMI Day 6 work. So just to refresh your memory on the different types of bonds that we have, there are two basic types that we learned about in chemistry and physical science. The first one is a covalent bond. This is one in which two or more atoms share valence electrons. So for example, we have hydrogen gas. Right here, when we start out, we have these two hydrogen atoms. Each of them has its own valence electron, just one. And when they come together, because each hydrogen atom can fit up to two valence electrons in its outermost shell, now each of them have a full outermost shell, and the sharing of electrons is going to keep them bonded together. So this is a covalent bond. In contrast, an ionic bond is one in which one or more valence electrons are transferred from one atom to the other. So what this does is it ends up creating oppositely charged ions which are attracted to one another. Our example is sodium chloride or salt. So down here we can see that this sodium atom had one valence electron. This chlorine atom has 7 valence electrons. Now there's an empty space in the chlorine atom, and it can hold one more. So when sodium donates its excess valence electron to the chlorine atom, it now has one more proton than it has electrons, so it's going to have a 1 plus charge. The chlorine atom now is going to have one more electron, which is going to give it a 1 minus charge. And because opposite charges attract, they're going to come together, they're going to get stuck together, and this is what bonds them together. Now, the physical science students, earlier this year, you all did a lab where you were given, amongst other items, a can and a balloon, and you looked at how positive and negative charges are distributed in an object. So here we started out with a neutral can, so it has the same number of positive and negative charges, and they are spread evenly throughout. Then we started out with a balloon, which you all rode with a piece of felt, which ended up making it more negative than positive. So it still has some positive charges, but it's got more negative. The can is what's known as a nonpolar or electrically non-polarized object. And the reason it's nonpolar is because the charges are spread evenly throughout. Now, after you brought the negatively charged balloon close to the can, what ended up happening was that all of the positive charges were brought close to the balloon, so on the right side, because the positive charges are attracted to the negatively charged balloon. And then the negative charges were pushed away to the other side. This can is now what is known as a polar object, because the charges have been separated. In other words, it has been electrically polarized. This brings me to our final slide, which is talking about polar and non-polar molecules. To refresh your memory, a molecule is an object in which two or more atoms are chemically bonded together. A polar molecule, therefore, is one in which the negative and positive charges are separated. In other words, water, which is also known as H2O, is made up of one oxygen and two hydrogen atoms. So here the gray dots represent valence electrons, and the straight lines between hydrogen and oxygen represent two valence electrons, in other words, a single covalent bond. Because oxygen is more electronegative than hydrogen, in other words, it attracts electrons more strongly than hydrogen does, that means that the valence electrons, are going to spend more time close to the oxygen atom, which means it's going to make it slightly negative. The hydrogen atoms are going to spend less time with the electrons, so that end of the molecule is going to be slightly positive. In contrast, a nonpolar molecule is one in which the negative and positive charges are not separated. They're just evenly distributed throughout. An example would be chlorine gas. Here, the gray dots again represent valence electrons. The straight line represents two valence electrons, which are shared between the chlorine atoms. And because each chlorine atom equally pulls on the valence electrons, it cannot be polar. In other words, the positive and negative charges in the molecule are just going to be evenly distributed. All right, so that sums up polar and non-polar molecules. Once you have watched this video or read through the presentation, you may move on to the worksheet.